All right, so we're going to continue our review for our MAAP test. So we are going to start today on that lovely rock cycle. We know it, we love it. Let's refresh our memory. So first, what even is the rock cycle? It just explains the series of processes that's going to take place that will change one type of rock into a different type of rock. So let's fill that in. Rock. Whoa, not all caps, no need to shout. Rock cycle. Okay, so we know there are three different types of rock. We have that igneous, we have that sedimentary, we have that metamorphic. So the cycle explains, okay, how does an igneous rock turn into a sedimentary rock or any other direction you want to go? Because just because a rock is one type of rock at one point doesn't mean it's got to be that way forever. Sometimes they change. It happens. So in order to be able to read this cycle, we know we got to focus on those arrows. Those arrows tell us everything we need to know. So the arrow is going to point from the starting product or the starting rock and point toward what it is becoming. So if we look right here, we've got the sedimentary rock. We know we're starting with the sedimentary rock because that's where the arrow starts, and it is pointing toward what it is becoming. So in this case right here, it is becoming a metamorphic rock. And even more importantly, on top of the arrow is explaining how that actually happens. So we know that a sedimentary rock becomes metamorphic by heat and pressure, which we're about to cover all of that nonsense. So the arrows are our besties here. We really got to focus on them. They tell you everything you need to know. Now it says, what is the rock cycle driven by? What that means is, what is causing these rocks to even go through changes? Because we all know changing is not always easy. It's easier to just stay the same. So there are certain things that are going to cause an igneous rock to become sedimentary or sedimentary to become an igneous rock. So those things are going to be temperature. We know what temperature is. Pressure. We know what pressure is. And weathering, which we just reviewed weathering on Friday. So we're all set for this. Awesome. So temperature, pressure, and weathering is what's going to cause these rocks to change. So let's take a closer look at what these different types of rocks actually are. So first things first, let's start with sedimentary. So these sedimentary rocks, I think they're the easiest ones to remember personally because they have the word sediment in it, which we know that sediment, let me type it down, is just a very fancy way of saying dirt or sand or clay or any of those tiny, tiny particles. That is going to make up sediment. So what happens is that sediment literally lays on top of each other. You can think of like in the bed of a river, how there's a bunch of sand or sediment that eventually gets laid on top of each other. So they lay on top of each other in a pile and get squeezed together or glued together, and we call that process compaction. So when something is compact, that means it's kind of like stacked and squeezed. Or cementation. So you can think of cement. You know what cement is. It's like if you go outside on the road, there's cement there. What cement is just a bunch of sediment kind of glued together. So cementation is the process of how that happens naturally in nature, right? So compaction and cementation, that is how sediment, and again, we can refer to our rock cycle to see this actually happening. Sediment turning into sedimentary rock, so the arrow is pointing toward sedimentary, through compaction and cementation. Now another even fancier word that you might see thrown your way is lithification. Lithification, it's kind of hard to say, but it means the same exact thing as compaction and cementation, just a fancier way of saying it, I guess. Now, if you want to go the other direction, if you want to take your sedimentary rock and turn it back into sediment, that is how we get that weathering and erosion, which we know weathering and erosion is just the breaking down of rocks or sedimentary rock into smaller pieces. So really, you can go back and forth endlessly with this. You can take some sediment, compact it, turn it into a rock, and then the weathering and erosion can break that rock back down into sediment. So you can go back and forth forever with this if you really want to. Now, one key thing about sedimentary rocks, I want this to be a major takeaway from today. If you are ever asked, what type of rock was this fossil found in? Guarantee you it's going to be sedimentary rock. Because think about how fossils even form. Fossils are formed when an organism dies, right? Step one. And then they're eventually buried in sediment. So think about the sediment covering over top of this fossil, and eventually that fossil gets in the middle of that rock when it goes through that compaction and sedimentation. So if you're ever asked, where's a fossil? It's going to be in sedimentary rock because that's what they get buried. Pretty easy. Sedimentary rocks. The next kind, this one's my favorite personally, is the igneous rock. I think they're kind of cool. So the igneous rock. Igneous rock is formed when either magma or lava is going to cool off, because we know magma and lava, it is hot. It's hot. So the magma or the lava is going to cool down and eventually harden to become a solid. So magma and lava kind of lives as a liquid. We know that. Look at it. It's kind of ooey gooey, scary. So when it cools down, it will harden and become a solid, which that solid is going to be that igneous rock. Pretty sweet. Now, the difference between magma and lava, it is a little tricky, and I think a lot of adults don't even know this one, so you're getting a good piece of knowledge here. It's called magma when it is still inside of the earth. So let's look over here. Think about a volcano, right? This is a volcano. If it is still inside of the volcano, it is referred to as magma. Or we know in that asthenosphere, inside the earth, that upper mantle, that is considered magma because it is still considered inside the earth. Now, if you want to get fancy again, with science, we love to put fancy terms for things. You can call magma intrusive. So if you hear of an intrusive igneous rock, that is a rock made of magma. So it was formed still inside the earth. Now lava, it's called lava when it's outside of the earth. So like this right here is going to be lava because this is outside of the volcano after it erupted. So like you could go up and touch it. You shouldn't touch it, you'll probably lose a finger, but it is outside of the earth. So now it is considered to be lava. So another fancy word we can use for lava or anything that is outside of the earth is extrusive. Think of like the exit means you're going outside, or exterior of something is the outside. So that can help you remember extrusive is the outside. Think exit. So if you hear of an extrusive igneous rock, that is a rock formed out of lava, meaning the volcano erupted just like this, and then the lava cools down and hardens to form that igneous rock. So intrusive inside, extrusive outside. Sweet. The last type of rock, and I know this is the one we kind of struggle with, but no worries, we're going to get it down, is the metamorphic rock. Metamorphic rock. So what a metamorphic rock is, it starts, where do I put myself? It starts as either an igneous or sedimentary rock and turns into a metamorphic rock. So what's going to happen, let's say we have our igneous rock, that lava cooled down to form our igneous rock. It's going to go through extreme heat and extreme pressure. So we're going to say heat and pressure. And it'll kind of shift a little, change, and turn into a metamorphic rock. So same thing with sedimentary rock. You already have a rock that's already been made, and it goes through heat and it goes through pressure. So let's really talk about what that means. So let's say here we have an igneous rock that is underneath the Earth's surface. So it is intrusive. Now that rock is just sitting there minding its own business, but it's kind of sitting next to some liquid magma, which we know is super, super hot, right? So that magma can heat up that rock, and maybe that rock is also buried underneath a lot of sediment. So there's a lot of pressure. We know when we have pressure from something, it's putting almost like a lot of weight onto something. So it's getting heated up by that magma. It's going through a lot of pressure, and it's going to kind of shift the way the rock actually looks. So after that rock is shifted and changed, it is now a metamorphic rock. So anytime you see heat and pressure put on a rock that already exists, that is that metamorphic rock. All right, that's all the blanks you had to fill in. Here is your cheat sheet. So this is another way you can see the rock cycle typed up. It actually shows the rock on the earth, where this one just kind of shows a picture of the rock. This actually shows it, taking place. So these over here are the key words that are going to tip you off to help you know that, okay, this question is talking about sedimentary, this one's talking about igneous, metamorphic. A reminder of where magma and lava is, magma being intrusive because it's inside, lava being extrusive because it is outside. And don't you dare forget, fossils, they're found in that sedimentary rock. Now, of course, we remember we have our independent practice. With this right here, we have a rock cycle, but it is incomplete. You might recognize this because we've already done this assignment kind of a long time ago when we first covered the rock cycle, but we didn't do as hot on it as I wish we would have. So we're going to do it one more time. I think we're more prepared this time. So what you need to do is take a look at the cycle and fill in the missing parts. So for example, right here, number 1 is on the arrow. So this is asking, okay, how did we get from sediment to sedimentary? Because remember, the arrow is pointing from sediment to sedimentary. So I remember that sediment turns into a sedimentary rock by compaction is one way. There are 2 other words you can put there. That'd be cementation and lithification, but I just need 1 word. So you're going to do that for each of these parts labeled on the rock cycle. Now, don't be silly. Don't play yourself. If you're like, I totally don't remember, use your cheat sheet. It's all right there. It'll help you out. When you're done with that, this next spot over here, it looks like a lot. I promise you it's not. It's pretty easy. What you're going to do is first read through the example and then tell me what key words helped you determine what that example is. So like this very first one says, through high temperature and pressure, this rock formed from a sedimentary rock. So since we have high temperature or heat and pressure, I know that this must be a metamorphic rock. So you can either just type M for metamorphic, or you can actually type out the whole word if you're feeling a little extra today, metamorphic. And then it says, which keywords help me determine my answer? So to do this, again, use your cheat sheet because I gave you the keywords that are going to help you figure out what rock the example is talking about. But if you're just so smart and you're like, I got this down, just type it from memory. So like I know it says high temperature and pressure. That helped me determine that it was a metamorphic rock. So you're going to do that for each of these examples. There's only 1, 2, 3, 4, 5 examples, and I did one of them for you. So this should be a walk in the park. If you have any questions when you're done with this or while you're completing it, please let me know. That's what I'm here for, literally. If not, I will see you tomorrow. Great work.